Right, so week 8, day 2. First calculation that we're looking at, it's the same as weekday 8.1, question 1. It is a mixed number, take away a fraction. And we've got 5 and 8/12, take away 1/4. Now, what I don't want you to do, I don't want you just to delve straight into a method. I don't want you to think, right, it's a subtraction. I know straight away I've got to convert everything into a common denominator, and I'll have to turn this into an improper fraction, etc., etc., etc. Because you don't. What you need to do is look at the numbers that you've got. Look at the digits, look at the fraction, look at the mixed number. Can you spot anything that would help you do it a little bit easier, that would help you calculate this a little bit easier? What do you notice? Well, straight away I can see, I know that 1/4 is a lot smaller of a part than 8/12. Yeah, 1/4 is smaller than 8/12. Did you also spot that? Okay, because that's what I want you to look at when you get a calculation like this. Look and think straight away without having to turn them into common denominators. Can you spot that one part is significantly smaller than the other? If you know for a fact it is significantly lower, like in this case, I'm going to do exactly what we did before, and I'm going to turn just my quarter into 12ths. I don't need to turn this into an improper fraction because I know that this is a smaller part, and I'm going to turn that into 12ths. So I'm going to leave that as 5 and 8/12, and I'm going to turn this into 12ths because I know I'll be able to subtract some 12ths from my 8/12, and I'll still have some 12ths left. I'll not be going into 4 and so many 12ths. I don't have to cross that boundary of the next whole number when I'm subtracting here. Okay, does that make sense? So I know that I need to multiply this by 2. Sorry, we're not working in 8ths, we're working in 12ths, Mrs. Walker. I need to multiply this by 3, which is going to give me 12ths. And then I also multiply my numerator by 3, which is going to give me 3/12. So can you see how just by looking at a quarter and knowing that it's a lot smaller of a part than 8/12, we can successfully just take away the 3/12 from the 8/12. So we've got 5 and 5/12. So we didn't have to do anything with these 5 and 8/12. And sometimes you don't. However, sometimes you do, and I will show you tomorrow what we do if the fraction that you're taking away here is greater than this fraction here. Okay, I'll show you how to do that tomorrow. Lovely. Okay, next question. Question number 2. Add 4.5, to 3 1/4. And again, don't just delve straight into a method. Look at it and think it's an addition. So what might I decide to do first? Okay, I'm going to add my 2 whole numbers first. Okay, 4 and 3, and I'm going to write this down here, equals 7. Yep, and then I'm going to cross that off, or rub it out, whatever works for you. So I know that I just have to add 1/2 and 1/4. Okay, I just have to add 1/2 and 1/4. So I'm going to write this down here, 1/2 add 1/4. And I know that 1/2 is equal to 2/4, so I have to add those together, which gives me 3/4. So I know that if I pull these two together now, my answer from my whole number and my answer from my fractions, I get 7 and 3/4. Okay, 7 and 3/4. This might be a good time to pause and have a good practice at adding some mixed numbers together. Because that's one way of working it out. Okay, right. Whoops. Next question. Which is greatest? Which is greatest? Another greatest question. We've got 4/8, 4/6, or 4/12. I'm going to say it again. Don't delve in to a method just yet. What's different to what we did yesterday? Well, yesterday we looked at 3/5. Let's write them down so you can see. We looked at 3/5. Sorry, we didn't. Telling a lie. We looked at 3/5 or 4/6, didn't we? 3/6 or 4/6. What's different today? What's the same and what's different? Well, you should be able to see that both the numerator and the denominator of the fractions we looked at yesterday were different. They're both different values, so we had to compare them by finding a common denominator, didn't we? Today we don't have to do that. We don't have to find a common denominator because our numerator is the same. Because our numerator is the same, we just need to look at our denominator and think, right, which denominator is going to be the smallest part? Are sixths smaller parts than twelfths? Well, no, they're not, because if we split a whole bar into twelfths, we know that we would have, fewer parts than we would if we had them in sixths. Okay. So we know that twelfths is our smallest because it's split into 12 equal parts and we have 4 of them. We then know that 8 parts are smaller in size than sixths. We have 8 equal parts and we have 4 of them. So we know that 4/6 is the greatest because it's only split into 6 equal parts and we have 4 of them. Okay, so just by looking at the denominators here, we can tell straight away which is the greatest fraction or which is the smallest fraction because our numerators are the same. Right. What's the value of the digit 1 in the number? I'm not going to say it out loud. In that number. And if you're not sure, what can you do to help you? Yes, absolutely. Put your place value headings on, starting with your ones. So you've got your ones, tens, hundreds. And remember, we have that pattern. Ones, tens, hundreds, ones, tens, hundreds, ones, tens, hundreds. So it's ones of thousands and tens of thousands. So we know that our digit 1 is in our thousands column. So the value of that digit is 1,000.